Hello, class 12th physics, chapter ray optics, important questions. So here we go. A glass lens of refractive index 1.5 is placed in a trough of liquid. What must be the refractive index of the liquid in order to make the lens disappear? It is possible if the liquid have same uh, refractive index that of lens, that is 1.5. You can directly write your answer 1.5 also, no problem, because they haven't asked explain or justify. Next, a converging lens of refractive index 1.5 is kept in a liquid medium having same refractive index. What would be the focal length of lens in this medium if in air it is 27.5? Once again, direct answer is infinite. And with some explanation, we can say that since 1 upon f in some medium is equal to eta, this is lens maker's formula, by the way. Glass with respect to medium, or what is that liquid actually? Minus 1, 1 upon R1 minus 1 upon R2. Now, this eta gm, what is this eta gm? Eta glass with respect to medium. So it is equal to eta of glass upon eta of medium. Well, actually, I use eta to represent this refractive index. So not to get confused. If you are habitual to write mu, go for it. If you habitual to write n, go for it, or any other symbol. So here it is refractive index actually. So for glass, they have said for both it is 1.55. So that is why it is 1. And if we put it here, so 1 upon f in that medium, in that liquid is 0. So if we reciprocate it, so f in medium is equal to infinite. Both ways you can express. How does power of convex lens vary if incident red light is replaced by violet light? So this is the case of some relation of focal length with refractive index. So we know that, okay, power is equal to 1 upon f, reciprocal of focal length, and then we can put that lens maker formula. And one more thing need to be remembered, that eta is inversely proportional to lambda in that medium. Let me explain this. Actually, eta equal to c by v, and c is speed of light in vacuum, and it is also nu lambda. Nu in vacuum, lambda in vacuum. Speed, c is equal to nu lambda. We know about it. And in case of v is also a speed of light. Nu will remain same. Remember, frequency remains same during refraction. But lambda will change to lambda medium. It is a variable. For different medium, it is different. This is constant. This will cancel out. So that is why eta is 1 upon lambda medium. Okay, so next thing. Now, since lambda is inversely proportional to lambda medium, and lambda of red is greater than lambda of violet, this implies that eta of red is less than eta of violet. And therefore, power is in direct relation with, according to lens maker formula, we can conclude that power for violet will be greater than power for red. Or if you want to give this answer directly, yes, you can go with it. How does power of lens vary? So it will replaced by violet, so it will increase. You can directly write it will increase, because they haven't asked justify, but I'm giving justifications side by side. And this can be, instead of going through all of it, you can go with just the definition of power of lens. Power means the converging and or diverging ability, extent of converging or diverging. So we know that red light is the least deviated and violet is most deviated. So lesser focal length means more power. Is for violet, is for red. Next. Okay. How does angle of minimum deviation? I use symbols to just avoid my, to just support my laziness. how does angle of minimum deviation of a glass prism of refractive index 1.5 change if immersed in a liquid of refractive index 1.3? Now see, we know the prism formula is sine delta m plus a by 2 upon sine a by 2 is equal to refractive index. Now, if, so it was glass. Now let us suppose medium has changed. Then instead of writing eta, we will replace it. Oh, now by the way, I'm replacing this. I think that it will change. So if we place that glass prism into a liquid, then instead of eta g, there will be eta g with respect to that liquid. And see, we know that this eta gl means eta g upon eta l. So that will be 1.5 by 1.3, which is something around 1 point, approximately 2. 1 point approximate, it will be 1.1 something. So 1.2, I'm approximating it. Okay. So earlier it was 1.5 and now it has decreased. And none other thing like A is fixed for this glass prism. If this value has decreased, excuse me, so this implies that this angle of minimum deviation must decrease. So comparing 1 and 2, delta m dash is less than delta m. We can conclude that. So the answer will be, it will decrease. Angle of minimum deviation will decrease. Oh, now, easy one. Two thin lenses of power 4 and -2 are in contact. Find focal length of combination. So directly we can do P equal to P1 plus P2, and then it is 4 minus 2, that is 2 diopter. Positive, of course, positive, negative are very important here. So F equal to 1 upon P, it is the focal length of combination, 1 upon 2, this is 0.5 meter. You can leave your answer here, and if you wish, you can convert it into centimeters. That's all. A glass lens, but remember, these type of questions come in the exams, and often students do some silly mistakes in these type of simple questions, and then they argue that question paper was difficult. So all right, so let's don't go into it. Next question, I haven't left a space here, so try to do it yourself and write me in the comment. State the condition. Okay, I will read it. A glass lens of refractive index 1.45 disappear when immersed into liquid. Predict the value of refractive index of liquid. So we have done it, this type of question earlier. State the condition or conditions for the phenomena of total internal reflection to occur. Number 1, refraction should take place from denser to rarer medium. See, I use these shortcuts just in order to save time and save effort also, but you people have to write them in full. The next thing is angle of incidence. Incidence should be greater than, must be greater than critical angle. Or we can say must be greater than IC. Calculate speed of light in a medium whose critical angle is 30 degrees. See, they have given us different levels to think. Speed of light, we will not go to speed of light first, we will focus on this. So we know that refractive index is 1 by sine of IC, that is 1 upon sine 30 degree. Sine 30 degree is 1 by 2, so it is 2. Refractive index is 2. And now we know that eta is equal to C by V, and C, actually it is given in the exam, C, value of C. So no need to worry about that, upon V. So V is equal to 3 into 10 to the power 8 upon eta, that is 3 into 10 to the power 8 upon 2, that is 1.5 into 10 to the power 8 meter per second. Next, A converging lens is kept coaxially in contact with the diverging lens of equal focal length. Of combination? Oh, equal focal length. Find focal length. I missed it. Find focal length of combination. Find f of combination. So both are by magnitude, both focal lengths are equal. So we can say that f for convex is plus x, and f for concave, converging and diverging, that is why opposite natures. So focal length of combination 1 by f1 plus 1 by f2. This is what the formula is. 1 by x minus 1 by x, that is 0. But answer is not 0. We have to reciprocate it, so it will be infinite. And see, if a convex lens and concave lens of equal focal length are combined together, they will act like a plain glass sheet. I can illustrate it here. And same focal length for this. So overall, it is not more than a glass sheet, and there will be no bending of light through this, converging or diverging. So this type of glasses are used in sunglasses, goggles. You would also wonder that the spectacles for to resolve those defect of vision are also look like these. No, but they are in fact have little more bulged out surfaces, or they have bit depressed in surfaces which we can't able to see, like that. So this question can be also asked that which type of lens is used in sunglasses. So a lens with infinite focal length is used. Okay, when light travel from rarer to denser medium, speed decreases, and or vice versa. If denser to rarer, speed increases. All right. Does this decrease in speed imply decrease in energy carried by light wave? Answer is no. Justify. So this time we can't run out by just saying no and that's all. They have asked for justification also. So remember, according to Planck's theory, energy of a light photon equal to h nu. Now during refraction, during or in refraction anyway, nu remains same, whereas okay, nu remains same, so also energy. However, speed decreases as wavelength decreases. Sorry, sometimes it happens. Now this question, when light, monochromatic light means single color light, travel from, that is fixed wavelength, travel from one medium to another, its wavelength changes, but frequency remains same. Explain. So actually same answer can be copied here, but we can still, so we can write it like this. Anything, just you can copy this thing also, or same thing I have written over here. According to Planck theory, energy is this. This energy remains unchanged during refraction. There's a long description about this also, but not required in your syllabus. So frequency changes, but wavelength changes. Frequency same, but wavelength changes as the speed changes. So in vacuum, it is C equal to nu lambda, but in medium to medium, wavelength changes. That is why speed changes, but frequency remains same. Next, under what condition does a biconvex lens of glass having refractive index mu g? They have given this. Actually, this time this eta you can read it like refractive index equal to mu g. So they have given mu g. Act as plain glass which immersed in the liquid. So when refractive index of refractive index of liquid, that is eta L, is equal to same as mu G, that is refractive index of glass, then it will act like a plain glass. We can also justify it using this equation. Now see, we can write it eta G by eta L minus 1 upon R1 minus 1 upon R2. We did it earlier. Both are equal, so it will come out to be 1 as from here. 1 minus 1, 1 upon R1 minus 1 upon R2, that is equal to 0, so F equal to infinite. So, which refers to infinite focal length, means it is acting like a glass sheet. For same angle of incidence, angle of refraction of 3 media, plural of medium, ABC are 15, 25, 35. We don't know the value of sine of any of these angles, but we know that sine 15 has least value, 25 has greater value, 35 has greatest value among these. So what we are going to do here, we can do it like this. This is my traditional way to do it. Eta A is equal to sine I upon sine 15. Eta B is equal to sine I upon sine 25. Eta C is sine I upon sine 35. Alright, angle of incidence for each case is same, so numerator is same. So we are interested in the denominator. So now we know that since okay, they have asked speed of light is minimum, so which has greater refractive index, so greatest refractive index among these three. Alright, so sine 15 is less than sine 25 is less than sine 35, and the value of sine here in each case is in inverse proportion to refractive index. So we can say eta for A is greater than eta for B is greater than eta for C, and the medium with the greatest refractive index will have least speed of light. Since eta is itself inversely proportional to speed of light in that medium, that is why V in A is less than V in B is less than V in C. So speed of light is minimum in A. That's all. Next, two thin lenses power this are placed coaxially, find focal length of combination. We did such question earlier, so I'm not repeating it. Write me in the comments, and if any problem, I will give its separate solution. All right, here, write the relationship between angle of incidence, refracting angle of prism, that is angle of prism in general. Angle of prism A is not in the focus. Angle of prism A and angle of minimum deviation delta for a triangular prism. Yeah, of course it is a triangular prism. So all right, so we have to go through this formula. Delta equal to relation between angle of deviation, angle of incidence, angle of emergence, and refracting angle of prism. Here the condition is given that delta is angle of minimum deviation. So when delta equal to delta m, then I equal to E. So what we will do, we will now replace the values. So delta is replaced by delta m, I is replaced with I is I, E is replaced with I minus A. So this will be the required relation for angle of minimum deviation. Delta m, this is the required relation, 2I minus A. When red light passing through a convex lens is replaced by blue color, how will focal length change? So similar question came earlier, but okay, I will do it here also. We know 1 upon F is equal to eta minus 1 and all of these terms. Okay, so and also we know that eta is inversely proportional to wavelength in that medium. And also we know that lambda of red is greater than lambda of violet blue. Here blue is asked, so we'll write it like this. It means eta for red is less than eta for blue. And according to this relation, we can also say this implies that focal length for red is greater than focal length for violet. Now, they have asked, when white light passing through convex lens is replaced by light of blue color, how will it change? So, focal length decreases. F decreases. If wavelength of light incident on convex lens is increased, how will focal length change? So similar question is there. Now wavelength is increased. Wavelength is increased. So that is, we can say if lambda is increased, if lambda is, I can't use those symbols again and again. So I'm actually, because in this collection, I try to explain you that what answer you could write in the exam and get full marks. So if lambda is increasing, so refractive index is decreasing for that wavelength. So F is increasing, as F1 upon F is equal to eta minus 1, and all those terms R1 minus R2. That's all. Nothing else is required. Okay, this question, 19th question, it is, I think I have left very small space for this type of question. A convex lens is placed in contact with a plane mirror. You can see this is a plane mirror. Actually, it looks like a sheet, but it is a plane mirror. Ignore this extra line here. Okay, a point object at a distance 20 centimeter on the axis has its image coinciding with itself. Find focal length of lens. Lens E, what is E? Lens. So actually this is the distance they have given, 20 centimeter. So answer is 20 centimeter. To justify your answer, you have to just complete this ray diagram. If it is coinciding with itself, it means light rays have retraced their path. And this is possible if they are being incident normally to plane, plane mirror. So we can say image will coincide with object if rays retrace their path. This is the one thing. And also rays incident on plane mirror normally. That is, become parallel to principal axis. It is possible only when, now think about it, in which case rays emerging from a point source become parallel when that source is placed in front of lens. It is when it is placed at the focus. It is possible only when object is placed at the focus. So F equal to 20 centimeter. That's all. All right, so